All right, this is part 2 of the lecture for this week. I'm going to talk about the mathematics. My friends told me that my online persona should be Mathy Matt, so this is Mathy Matt coming at you with some math strategies. All right, so you did a problem about the little houses. I'm going to talk about 2 strategies. The most common strategy I saw was 3n plus 2. So I've got 8 houses here, but we're going to imagine it's any number of houses, and I'm going to walk through where the 3n plus 2 comes from in the image. So we've got the 3, which I'm going to highlight in orange because each house has 1, 2, 3 sides. 2 on the roof, 1 on the bottom. That's true for both the end houses and the middle houses. So now let's talk about where that n comes from. The n comes from the fact that we're going to have n number of houses. That's what we were told the variable stood for in the problem. So therefore, when we extend that out, we have 3n to cover all those tops and bottoms of the houses. And then finally, we have the plus 2, which I've highlighted in red, and that's from these 2 end sides on the left and right. So that's where that strategy came from. That's the most common strategy I saw. I also want to share, some people broke this down in a slightly different way. They looked at the bottom as n, they looked at the top as 2n, but those still combined to be 3n, and then they had the plus 2 at the end. I also want to share a second strategy that I saw, and I'm going to be honest, at first glance when I saw this, I thought it was wrong, and then I had to think about it for a minute and go back and look at their pictures. And that is one of the things I love about doing math with multiple strategies, is I often learn new things from you, and you'll learn new things from your students. So their rule was 2n plus 4 plus n minus 2. So I've got the same houses. Let's talk about where this 2n comes from. I have it highlighted in orange again. And I'm not going to break down in quite as much detail, but they took 2n as the number of edges along the top. So each house has 2 on the roof, and so we end up with 2n. And then we also have 4 more that we're going to try to find here in purple. So we've got 1, 2, 3, and 4, kind of along the left and right sides. And then finally, we have to deal with this n minus 2. So we've got just these uncounted bottoms along the middle here, but we don't have the full n, we don't have the full length, so we only have n minus 2 of those, and so we'll count those in green. So that was a different strategy that I had not thought of and I enjoyed seeing. All right, the other problem that was an algebra problem was the pool problem. So the most common strategy is n times quantity n minus 1. This one's fairly straightforward. We had pools that looked like this. We were told that the bottom was n, the number of blue tiles in the pool was what n was. I'm not sure why that square disappeared, I apologize. So that we have n squares in every row. And then we have this n minus 1, and the pools all turned out to be n minus 1 tall. So here's n is 5 in our picture. So it's 5 per row, and it's only 4 rows tall. So we have n by n minus 1, and we multiply those to find the number of squares in an array. And then there was another strategy, which I had not thought of. Again, that's why I like doing these problems, is I learn new strategies, which was n times n, and then minus n. So it's similar. We still have n squares per row, or n squares going along the bottom of our array. And now we got to figure out where this second n comes from. And what we're going to do is we're going to imagine, I want you to keep your eye on this top row here, and imagine that we filled that row up with water. Then we would have a square, an n by n square. So we have n times n to get the number of blue squares. But we should have never really counted these top blue squares. So we're going to highlight this in yellow, and because we shouldn't have counted them, they're not actually part of our pool, we're going to subtract that off. There are other pool problems you could do, and I've actually revised this. So there's a first pool problem, which is what I'm going to share with you as the extension, which is we could also ask how many sidewalk tiles are there around the nth pool, and how do you know? So there's more than one kind of question we could ask about this pattern. And that's it. I'm not going to go over the number talk activity because that was more straightforward, but I did want to share a couple of strategies I'd seen with the pool problem and the little houses.